Hello dear students, good evening. Today we are going to discuss in our fifth session on three-dimensional geometry. And before I proceed further, could you please confirm that you are able to view the screen properly and able to hear my voice very clearly?
Yes, sir.
Okay, great. So the point is that what we are going to discuss today is the equation of a plane perpendicular to a given vector and passing through a given point. That is the first one. Second one, we will discuss the equation of a plane passing through three non-collinear points, and then we will discuss the equation of a plane in intercept form, and then we will solve relevant questions as well. Now, if you recall, in the previous session I have mentioned that when you find the equation of a plane, there are broadly three categories. The first one is that the equation of a plane in normal form, which is discussed in the previous session. Okay, so you can look into the concerned YouTube to know about that, and I will create the playlist and share with you earlier containing all the sessions. Now what today we now, apart from that normal form, there are two more forms. The first one is that the equation of a plane perpendicular to a given vector and passing through a given point. That is one. And second, we will discuss about that equation of a plane passing through three non-collinear points. An equation of a plane in intercept form, this is actually a special case of equation of a plane passing through three non-collinear points. That we will discuss later. Now let us concentrate on finding the equation of a plane perpendicular to a given vector and passing through a given point. Now dear students, perpendicular to a given vector, there could be many planes. Okay, for example, you look into this vector which you see here, this arrow vector. Now perpendicular to this vector, there are many planes. One plane is this one, second plane is this one, third plane is this one. Like that, there could be many planes. In the diagram I showed only 3 planes, but there could be many planes. But out of all those planes, if I give a specific point, passing through that specific point, only one plane is possible, okay, which is perpendicular to a given vector. For example, if we consider this particular point P having coordinates x1, y1, z1, and we need to construct a plane which is passing through this, which is actually containing that particular point P having coordinates x1, y1, z1 and perpendicular to a given vector. Okay, then how we can, then the plane is unique, that is only one plane, and we are going to find the equation of a plane. So now dear students, what we have, the two information what we have is that the first information is that the plane is passing through a fixed point, that means its position vector is known to us. So let a plane pass through a point with position vector a vector and perpendicular to a vector n vector. So that means two information is known to us. The first information is vector a, which is the position vector of the fixed point through which the plane is passing, and the vector n, that is the vector which is perpendicular to the plane. So by means of these two given information, we are going to find the equation of the plane. So we are first we are going to find the equation of a plane in vector form, and then we will find the equation of a plane in Cartesian form. The first one, so let us concentrate on the second diagram. So this is the plane, as you see, this is the plane which is passing through a fixed point, the point A having the position vector a vector. and it is perpendicular to the vector having vector in this one. Fine. So now in that, on that plane we took arbitrary point P having coordinates x comma y comma z, and in vector form we can say it is having a position vector r. That means what? That OP, that vector is vector r, okay, and that vector is, that point P is an arbitrary point, it means any point on that plane. So OP vector is r. Now the fixed point A is having the position vector A. That means what? OA vector is nothing but the vector A, and we have, so let me write the vector A properly. So it is a A, and we have the the vector which is perpendicular to the plane, that is the vector n. Okay. Now one thing what we can say is that the vector AP is perpendicular to the vector n, correct? Obviously, because if we join A and P, then what we get? We get this vector AP. Okay, that AP vector is perpendicular to the vector n. Now when two vectors are perpendicular to each other, what happens? Their dot product becomes 0. So that means what we can say, AP dot n, AP vector dot n vector is equal to 0. So that means what we can say, that AP vector, okay, dot n vector is equal to 0. Left hand side is a dot product which is a a scalar quantity, because dot product is also known as a scalar product. That's why right hand side is a 0 scalar quantity. Now what is AP? The vector AP is nothing but, if you look into this triangle, okay, that triangle OAP. So what I am mentioning, dear students, if you consider the triangle OAP, then from this triangle law, what we can say, the vector AP is nothing but the vector AO plus vector OP. So vector AO plus vector OP, that is actually AP vector. So that means what? That vector dot n vector is equal to 0. Now what is AO? OA vector is A, that means AO vector is minus A. So minus A vector plus OP vector is R vector dot n is equal to 0. So that means what we can say, dear students? We can say that R vector minus A vector dot n vector is equal to 0. That is the equation of the plane passing through a fixed point having position vector A and perpendicular to a vector n vector. So this is the equation what you see. So that is the Cartesian equation. Now how we can derive, that is the vector equation. I repeat once more, whatever we have derived now, this one, that is a vector equation of a plane passing through a fixed point having position vector A and perpendicular to a vector n vector. Now let us derive its Cartesian form. So how to derive the Cartesian form? Now let us consider the point A is having coordinates x1, y1, z1, and the point P is having coordinates x, y, z. So then in the component form, what will be the vector A? A will be x1 I cap plus y1 j cap plus z1 k cap, and the vector R will be x I cap plus y j cap plus z k cap. Now let us consider the vector n as capital A I cap plus capital B j cap plus capital C k cap in the component form. By the way, what is ABC? ABC is nothing but the direction ratios of the normal to the plane, capital A, capital B, capital C in this case. Okay. So now as we already derived the vector equation as r vector minus a vector dot n vector equal to 0. So, let us apply all these things, and we get from here to here, and finally from here we get this is the required Cartesian equation of a plane. So, this is the one, the Cartesian equation of a plane. So, let me mark it. So, this is the Cartesian equation of a plane passing through a fixed point x1, y1, z1 and perpendicular to a vector n vector, which is described in the component form as capital A I cap plus capital B j cap plus capital C k cap. Now, one information I said a minute back, but I am just repeating once more. Whenever you see an equation of a plane described in the Cartesian form something like this, one thing though you are sure, the plane is passing through the point x1, y1, z1, and also you can consider the direction ratio of the normal to the plane is capital A, capital B, capital C. Okay, I hope this is clear that how to derive the equation of a plane perpendicular to a given vector and passing through a given point. Now, let us proceed to the next point, and here what we are going to do, we are going to solve a question together. Okay, please open your notebook, do along with me so that it will be more clear. The question here is that find the vector and Cartesian equation of the plane which passes through the point 5, 2, minus 4 and perpendicular to the line with direction ratios 2, 3, minus 1. So, what is given? The two information given. It is passing through a fixed point having coordinates 5, 2, minus 4 and is perpendicular to the line having direction ratios 2, 3, minus 1. That means, in other way we can say the direction ratio of the normal to the plane is 2, 3, minus 1. Now, we need to find both the vector equation and Cartesian equation. We just derived the formula, we need to apply the formula and proceed further. Let me bring the solution and let me explain from here. Okay. So, dear students, as the fixed point is having coordinates 5, 2, minus 4. So, its position vector will be a vector equal to 5 I cap plus 2 j cap minus 4 k cap, and n vector, that is the perpendicular to the plane, will be 2 I cap plus 3 j cap minus k cap minus k cap. Why? Because according to the question, the perpendicular to the line having direction ratios 2, 3, minus 1. So, the vector n which is perpendicular to the plane will be described in the component form as 2 I cap plus 3 j cap minus k cap minus k cap. Every time I am saying k cap, sorry, wrong, k cap. So, now what is the equation? We just derived r minus r vector minus a vector dot n vector equal to 0. So, we are applying here r vector minus a vector, we apply here dot n vector equal to 0. That is the Cartesian equation. Sorry, I am so sorry, this is the vector equation. Okay. So, whatever we have derived here, this is the vector equation. Now, according to the question, we need to derive the Cartesian equation as well. So, now r vector is nothing but x I cap plus y j cap plus z k cap. Why? Because x, y, z is an arbitrary point on the plane. R is an arbitrary, r vector is an arbitrary position vector of any arbitrary point on the plane. Na? So, that is why what we can write is that we can write the r vector is nothing but x I cap plus y j cap plus z k cap. Now, apply this one. and we get this equation, and we simplify, we get this equation, we further simplify, we get this equation. Now apart from that, there is another way also you can find it out, the Cartesian equation, very simple. We know, if you recall that just a few minutes back I said, if a plane passing through a fixed point x1, y1, z1 and is perpendicular and the direction ratio to the normal to the plane is capital A, capital B, capital C, then what is the equation? Capital A into x minus x1 plus capital B into y minus y1 plus capital C into z minus z1 is equal to 0. So according to our question, x1, y1, z1 is nothing but 5, 2, minus 4, and capital A, capital B, capital C is nothing but 2, 3, minus 5. So our required equation is becoming that 2 into x minus 5 plus 3 into y minus 3, sorry, plus 2 into, because sorry, no, it is correct, 3 into y minus 2 and minus 1 into z minus z1. So z minus minus 4, that means z plus 4, that is equal to 0. Now if you look into this equation, whatever I have written and this equation, both are same. Okay, so this is the way also you can proceed. Now dear students, let's proceed further. The next one, we are going to find the equation of a plane passing through 3 non-collinear points. Okay. Okay, so one point I would like to mention is that before the class, when it should be here dot product, I will explain this too. Okay. So dear students, the discussion what we are going to do, that equation of a plane passing through 3 non-collinear points. So why it is non-collinear, we will discuss after some time. First let us derive. So let us have 3 points, 3 non-collinear points R, S and T, and having the position vectors A vector, B vector and C vector respectively. So let R, S, T be 3 non-collinear points on the plane with position vectors A vector, B vector and C vector respectively. So that means what, dear students? This is the point R, this is the point S and this is the point T. And R vector, that position vector for the point R is OR. So that means this is the vector OR, that is A. This is the vector OS, it is B, and this is the vector OT is C. Now this 3 information is given to us, that A vector, B vector, C vector, and what we need to find? We need to find the equation of the plane. So now, as usual, to find the equation of a plane, we will consider an arbitrary point on the plane. So let us consider an arbitrary point P on the plane having position vector R. Fine. Then what we can say, the vector, one thing what we can say is that both the vector RS, what I wanted to say is that R, S and T are given. Na? So this vector RS and this vector RT are on the plane, correct? So that means the vector RS cross RT is perpendicular to the plane. So the vector RS cross RT is perpendicular to the plane containing the point RS and T, obviously, because we know A cross B is a vector which is perpendicular to the plane containing the vectors A and B. In this case, there are 2 vectors RS and RT. Now, what is the vector R? R be the position vector of the point P on the plane, arbitrary point. So, obviously, that vector PR, that vector PR must be perpendicular to the vector RS cross RT. So, what I wanted to say is that, dear students, is that the vector PR is a vector what? PR is a vector which is on the plane. So, that PR vector is perpendicular to the vector RS cross RT. So, that means if they are perpendicular, their dot product has to be 0. So, PR vector dot RS vector cross RT vector is equal to 0. Now, what is PR vector? PR vector is nothing but PO plus OR, correct na? So, that means what? PR vector is nothing but that PO vector plus OR vector, okay, dot RS vector is what? RS vector we know it is the position vector of S minus position vector of R. What is the position vector of S? It is B vector, and position vector R is A vector. So, what we can say here is that B vector minus A vector, that is the vector RS cross. What is the vector RT? That is the position vector of the point T, that means C vector minus position vector of the point R, that is A vector, that is equal to 0. Now, what is PO? PO, the OP vector is R, that means PO vector is minus R vector plus OR vector is nothing but A vector, correct. So, that dot means this vector minus R vector plus A vector dot B vector minus A vector cross C vector minus A vector is equal to 0. So, now we can make it in a very little proper form, minus R vector plus A vector. Instead of that, we can write R vector minus A vector dot B vector minus A vector cross sorry, C vector minus A vector, that is equal to 0. So, this is the required equation. Okay, this is the required equation. This is the required vector equation of a plane passing through 3 non-collinear points, okay, whose position vectors are A, B and C. So, this is the vector equation. I hope it is clear, and that same equation is actually mentioned here, correct. Now, dear students, what we are going to discuss? We are going to discuss what is the concerned Cartesian equation, Cartesian format. Okay, so that we are going to discuss now. So, for that, what I am going to discuss, let me place that particular point here. Okay. So, dear students, so as there are 3 non-collinear points, okay, the non-collinear points are we consider RST. So, in the Cartesian coordinate system, let us consider their coordinates as x1, y1, z1, x2, y2, z2 and x3, y3, z3. Then, as we know that RP that we already discussed here, let me go back little bit, that PR dot RS cross RT equal to 0. Okay. So, we found here the what is the RP vector. RP vector we found it here. Okay, rp vector is nothing but, it is the position vector of the p minus position vector of the point r, correct. Similarly, we find the rs vector, position vector of the point S minus position vector of the point r, and rt vector, that is position vector of the point T minus position vector of the point R, correct. And what is the equation? PR, we just PR means here I can write RP also, RP vector dot RS vector cross RT vector is equal to 0, na? That was the vector equation. So that one we have actually applied here, because if you remember, that is A dot B cross C is actually expressed in the determinant form like this. So this one, whatever you see, is that this determinant, okay, is the corresponding Cartesian equation of a plane passing through three non-collinear points having coordinates x1, y1, z1, x2, y2, z2, and x3, y3, z3. Now, dear students, why these 3 points has to be a non-collinear points? So let us see what will happen if these 3 points are collinear points. Suppose these 3 points R, S and T are collinear, they are in the same line. Then we can have many planes passing through these 3 collinear points. One plane is this, one plane is this, one plane is this, one plane is this, as if like this, that you are having a book, okay, where that RST is the the 3 points along the line of the binding of the book. So that means if I write it in the green color, so as if this is the binding of the book and these are the planes of the different pages of the book. So then we cannot find the unique plane passing through 3 collinear points. So to find the equation of the unique plane, the 3 points which are given must be non-collinear. Okay, they should not be in the same line. Collinear means they are in the same line. Non-collinear means they are not in the same line. Okay, that means you cannot construct a single straight line passing through all the 3 points. That is what it's called, the 3 points are non-collinear. I hope it is clear. Now we can proceed further. Okay, and the next one we are going to discuss a couple of questions. Okay, so let me first place the question here, dear students. Please do along with me, as usually I say. So the question here is that we need to find the vector equation of the plane passing through the points R 2, 5, -3 is let me use a red color, R 2, 5, -3 is -2, -3, 5 and T 5, 3, -3. So we can find the corresponding vectors A, B, C. Okay, A is this vector corresponding to the point R. This is the B vector in the component form for the point S, and C is the for the point T. Done. So we know what is the equation. So we have already learned this equation, that R minus R vector minus A vector dot R S vector cross RT vector is equal to 0. So that means this vector R vector minus A vector dot B vector minus A vector cross C vector minus A vector equal to 0. And once we apply all these values, values of the vector A, vector B and vector C, we get this is the required equation. I hope it is clear, dear students, that this is the required vector equation of the plane passing through the points 2, 5, -3, -2, -3, 5 and 5, 3, -3. Now let us go to the next point. Okay. So here we are going to discuss equation of a plane in intercept form. So dear students, this is a special case of the previous topic, whatever we discussed, that equation of a plane passing through three non-collinear points. Okay. So the special form what we are going to say is that intercept form of the equation of a plane. Okay. So let us consider the plane. As you see here, PQR is the plane, and this plane is making an intercept in all the three axes x, y and z. So that means this plane is passing through 3 points. One point, the first point is on the x axis having coordinates a, 0, 0. We name this point as point P. Second point is point Q on the y axis having coordinates 0, b, 0. So why? Because any point on the y axis is having the x and z coordinate 0. That's why it is 0, b, 0. In the similar logic, the point P is having coordinates a, 0, 0. Why? Because any point on the x axis having y and z coordinates 0, and the point R on the z axis, okay, having coordinates 0, 0, c. In the same logic, any point on the z axis is having x and y coordinates 0. So these are the three non-collinear points. Okay. The first point P, a, 0, 0. Second point Q, 0, b, 0, and third point R, 0, 0, c. Then we are going to find the equation of the plane. So now, dear students, to find the equation of the plane is that what we are considering. Let us consider the general equation of the plane as ax plus by plus cz plus d equal to 0, where d is not equal to 0. Why d is not equal to 0? If d is equal to 0, then the equation is turning to be, means what I wanted to say, that if d is equal to 0, then this equation is turning to be that ax plus by plus cz is equal to 0. That means the plane is passing through the point 0, 0, 0. That means the plane is passing through the origin. That means if a plane is passing through the origin, then what happened is that we are not able to get all the three intercept at the same time, x, y and z. Okay. So that is why we are considering that d is not equal to 0. Now this plane, that is ax plus by plus cz plus d equal to 0, this plane is passing through all the 3 points a, 0, 0, 0, b, 0 and 0, 0, c. So let us apply that. Once we apply that x equal to, let us apply means what? When the plane is passing through the point a, 0, 0, that means in that equation we can apply x equal to a, y equal to 0 and z equal to 0, and then we get this equation. So we get capital A equal to minus d by a. In the similar manner, when we apply x equal to 0, y equal to b and z equal to 0, that is 0, b, 0, then we get this equation, and that leads to b equal to, means capital B equal to minus d by b. In the similar manner, when we apply 0, 0, c, we get this equation, and it gives capital C equal to minus d by c. Now apply all these values. Let me use the green color. Apply all these values of capital A, capital B, capital C, and we get the equation of the plane is this one. Very important one. So equation of a plane having x, y and z intercept as lowercase a, lowercase b, lowercase c is, the equation is x by a plus y by b plus z by c equal to 1. Now here in this context, I would like to tell you a little bit about the two-dimensional coordinate geometry. If you recall, dear students, suppose these are the coordinate axes, okay, and this is origin, this is x axis positive direction, this is x axis negative direction, this is y axis positive direction, this is y axis negative direction, Now if we have a straight line something like this, okay, and it is having the x intercept a of length a and y intercept of length b, then if you recall, what is the equation of the straight line? Equation of the straight line is x by a plus y by b is equal to 1. Now this is an, whatever the equation you see here, that is an extension of this thing in the 3 dimension, okay, but not a straight line, but it is a plane. But to remember, I bring this analogy of the 2 dimensional coordinate geometry, the equation of a straight line in intercept form. So what we conclude is that if a plane having a x intercept of a unit, y intercept of b unit and z intercept of c unit, the equation of the plane in Cartesian form is that x by a plus y by b plus z by c equal to 1. For this kind of equation, this is generally vector equation is not asked, but if the vector equation also asked, you can find the position vector of p, q and r and then apply the concept whatever we discussed earlier during the theoretical discussion. Okay, dear students, so now let's proceed further. The next one, what we are going to discuss is question we are going to discuss based on whatever we just learned in the intercept form. Okay, the question is here. Find the equation, let me read out the question, dear students. Find the equation of a plane with intercept 2, 3 and 4 on x, y and z axis respectively. Show the intercept of 2, 3 and 4 on the x, y and z axis. So how to find? We know the intercept form equation is that x by a plus y by b plus z by c equal to 1. In this case, a equal to 2, b equal to 3 and c equal to 4. Okay, so we apply all these values and we get the required equation as this one. So this is the required equation, and if we simplify by taking the LCM of the denominator, we get the equation in the general form as 6x plus 4y plus 3z equal to 12. This is the required equation. I hope this is clear. Now let's proceed further. So dear students, what we are going to discuss now is that we are going to discuss the plane passing through the intersection of 2 given planes. Okay, so let us consider 2 given planes. The first plane is the plane pi 1. So this plane is given, and the second plane pi 2, that is also given. Now passing through these two, what is the intersection then? Intersection is this one. Okay, so this is the intersection. Now we can have many planes passing through the intersection of these 2 planes. In the same analogy what I gave, if we consider this intersection as a cover, the binding line of the book, and if you consider the pi 1 and pi 2 as the 2 cover, front cover and back cover of the book, then pi 3, whose equation we are going to find, is that consider the different pages of the book. Now we can have different pages, or we can say is that the same pi 3 can be make different inclination, and we get different planes. Okay, so we need to find the general equation of that plane. Okay, how to find? Let's find it out. Now as equation of the plane pi 1 and pi 2 are given, let us consider equation of the plane pi 1 as r vector dot in1 cap equal to d1. That is a standard equation of a plane in the vector form, if you recall. Similarly, the equation of the plane pi 2 as r vector dot into cap equal to d2. Okay, so now position vector of any point on the line of intersection must satisfy this whatever you see here in the pi 3. So whatever the the line I have drawn here now, So that red line, this one, okay. So this one, that intersection, the plane containing the both the going through the passing through the intersection of these two planes pi 1 and pi 2 must satisfy what, that I am going to bring it here, okay. Just give me a second. Sorry. So we are considering position vector as a t on that line, on that red line, whatever I showed you earlier, okay. So if I go back, so this is the one, okay. So in that red line, okay, so we consider any arbitrary point is having the position vector t. So if t be the position vector on the line, then that position vector must satisfy both these equations, this equation and this equation. So that means what we get, t dot n1 cap equal to d1 and t dot n2 cap equal to d2. Now for all real values of lambda, we can get this from these two equations, okay. So what I say, from these two equations we can get this, okay. Why lambda is coming? Lambda, if you vary, you will get different planes, like a different pages of that book, in which pi 1 and pi 2 are the two end cover of that book. So instead of that n1 cap and n2 cap, we are considering the vector n1 vector and n2 vector, okay. That can be easily done actually, dear students. So if the vector, we know the standard equation is that r vector dot n cap equal to d. So but here if you write, instead of n cap, if we write n vector equal to d, that is also fine, because what is the general equation? General equation is that instead of that vector, here it is a cap, here it is a cap, correct. Now that cap we can write is nothing but unit vector, so that is nothing but r vector dot n vector divided by mod of the n vector, that is equal to d, okay. So from there we can find that r dot n vector equal to d into mod of n vector. So that is also, in that way also you can express the equation of a plane. That is why we are considering these two planes, that r vector dot n1 vector equal to d1, that is the equation of the first given plane, and the equation of the second given plane is r vector dot n2 vector equal to d2. Then what will be the equation of the vectors passing through the intersection of these two given vectors is r vector dot n1 vector plus lambda n2 vector equal to d1 plus lambda d2, okay. So that also we can find the equation of this plane, we can also find in the Cartesian form, okay. So let's discuss the Cartesian form of that one, okay. So here n1 vector will be what? So in the component form we can express this is the n1 vector, okay. This is the n2 vector, r vector is this one, xi cap plus yj cap plus zk cap. Now all this that component form expression of these vectors, if we apply here, we get this is the equation of the vector, equation of the plane in the Cartesian form. So I repeat once more, that equation of a plane which is passing through the intersection of the two given planes a1x plus b1y plus c1z equal to d1 and a2x plus b2y plus c2z equal to d2 is, Cartesian equation is a1x plus b1y plus c1z minus d1 plus lambda into a2x minus plus b2y plus c2z minus d2 equal to 0. Now lambda is what? Lambda is a real number. You vary the different values of lambda, you get different equation of the plane, as if the different pages of that book according to this diagram, correct. Now generally in any numerical questions, a hint will be given to find the value of lambda, and we will see one such example today. Okay. So dear students, so let's look into one question here. Okay. The first question I am going to place it here, dear students, that find the vector equation of the plane. Find the vector equation of the plane passing through the intersections of the plane. The first plane is given r vector dot I cap plus j cap plus k cap equal to 6, and second vector is that r vector dot 2 I cap plus 3 j cap plus 4 k cap equal to -5, and the hint is that it is passing through the point 1 comma 1 comma 1. Okay. So here according to the our formula, n1 vector is this I cap plus j cap plus k cap, n2 vector is this 2 I cap plus 3 j cap plus 4 k cap, d1 is 6 and d2 is equal to -5. So we know what is that equation of a plane passing through the intersection of these two planes is r vector dot n1 vector plus lambda n2 vector equal to d1 vector d1 plus lambda d2. Now all these values of n1, n2, d1, d2 we apply and we get this is the equation, and after simplification we get this is the equation. Lambda is a real number. Now as this particular plane is passing through the point 1 comma 1 comma 1, that hint is going to help us to find the value of lambda. How? I am going to show it to you now. Now as r is a vector, so we can consider this is equal to x I cap plus y j cap plus z k cap, and after that we apply it here and we get from the previous equation we get this equation. Okay, so let me go back to the previous equation, dear students. So that was the previous equation. So from this equation we get this equation after considering that r vector as x I cap plus y j cap plus z k cap. So after that we simplified that dot product we know now, dot product simplification we have done. Okay, we know I cap dot I cap equal to 1, j cap dot j cap equal to 1, k cap dot k cap equal to 1, I cap dot j cap equal to 0, j cap dot k cap equal to 0, k cap dot I cap equal to 0. Using that one after simplification we get this is the equation. Okay, this is the equation. Now that plane is passing to the point 1 comma 1 comma 1, so we apply and we get the value of lambda. Okay, we get the value of lambda. After that we apply the value of lambda. Where we apply the value of lambda, as according to the question we need to find the vector equation, we apply the value of lambda in this equation, this one. Okay, and after applying this value of lambda, let me show you in the different color. If we apply it here, we get the vector equation of the plane as this one. Okay, this is the required vector equation of the plane. I hope it is clear that and after simplification you can get this one, and further you can get this one. Okay, so dear students, so what is mean by that it is passing to the point 1 comma 1 comma 1. So I go back to the previous diagram here. If you see that there could be passing through the line of intersection of these two plane pi 1 and pi 2. This is the red color, no? So we can have many planes, as I was telling that if we consider pi 1 and pi 2 are the two end covers of a book, then pi 3 could be any pages of the book. Okay, so what could be one such could be another plane could be something like this. Okay, one plane could be something like this. Many planes possible. Now one plane could be something like this. I can describe in the green color like this. One plane. All these planes, if you see, green color, red color, and whatever is given in the original diagram in the blue color dotted line. Okay, all are actually passing through the intersection of the given planes pi 1 and pi 2. Now, not all planes are passing through the point 1 comma 1 comma 1. Out of that, exactly one plane is passing through the fixed point 1 comma 1 comma 1. Okay, and that equation we find it out. So, if you see without 1 comma 1 comma 1, what is the generic equation? This is the generic equation. In fact, I can say this is the generic equation of the plane in the vector form, and this is the generic equation of the plane in the Cartesian form. To find the exact equation which is passing through the point, generic means what? Different pages of the book. Now, to find the exactly one page which is passing through the point 1 comma 1 comma 1, page means the plane, page is referred here as a plane, passing through the point 1 comma 1 comma 1, we apply this and we find the value of lambda. Okay, so this is the way we find the equation of this plane. So, with this note, let me conclude the class here, unless you have any specific question, and please do let me know in case you have any question. Otherwise, we can conclude.
No, sir, I have no questions.
Okay.
No questions.
Thank you very much. All right.
Thank you, sir.
Thank you, sir.
Bye.